Rain gardens are very important because they give you an alternative plan for handling stormwater.
You have an area that is a low-lying area behind Johnson Hall, next to Swan, close to Burkham, and it gets all this runoff that I was saying of water, as well as all the pollutants that are in that water. And it makes its way through sewer systems, down through an Ive Street drain, and through that drain over to the Muskegon River. 80% of the runoff from about Cat Key Golf Course, across Perry, down through main campus, and over through South and North Campus to the Muskegon River, 80% of that water runs through this Ive Street drain. If we can slow down that water through various mechanisms, we're going to have major impacts on pollutants, slowing the stormwater, and we can actually evaporate more of that water off. The Muskegon River Watershed Assembly actually had experience putting in several rain gardens, one in Big Rapids at St. Peter's, another one up in Cadillac, I believe, at their library. So they decided to do something innovative and involve different programs across campus through this program called the Academic Service Learning. And we were going to try to get different faculty involved with each of the components of design to implementation to future management of this rain garden on Ferris's campus.
Dr. Heron brought up to me the opportunity to convert the design from an actual architect into the computer program on here so we get more hands-on through the students. I could take a picture of the plain site right now, grass, that's it. I could cut all the grass out, put all the sidewalks in, layer it, put all the quarries in, and then start putting in the plants that they want, the amount, the size, the scale, the color, everything.
It is a real-world experience for our students because what they're doing is they're designing it from the beginning. They're going out there collecting the survey data. It's a really good experience for them.
We want to now have plants that have extensive root systems, are native plants well adapted to this area and can suck up water and then transpire it and evaporate it off. It'll be about 18 inches below the ground level. And then we're going to have amended that 18 inches up, so what we have in the rain garden won't be the heavy clay soils that are there right now, but it'll be compost, and it'll be leaf mold, and it'll be some organic topsoil. And then you'll have some mulch that we put on top, which will probably be like wood mulch chips. Because that'll be the ideal growing area for the roots, the plants will prefer to keep their roots in those 18 inches of soil, and then they won't try to penetrate the hard clay pan below that, which is where that's the reason why we don't have a lot of plants other than grass growing there right now, is they can't penetrate this hard clay. So we're gonna make it better for the plant's roots.
Plans of a cistern that stored fresh water within had been part of the MRWA's plan at the beginning of the project. Unfortunately, this plan has been changed. Professor John Schmidt will explain the reasons for this cut from the project.
The idea of a cistern as a holding basin, simply as a holding basin, was difficult to incorporate into any kind of a design that we could see. The depth of the rain garden being only a couple feet, you really can't have a very tall cistern. The first design called for a cistern that was partially up on the hill and was going to be controlled by somebody who would release water when the rain garden got dry. Well, if this is supposed to be a rain garden and it works with natural type of materials, you shouldn't have to recharge it.